It has been known for a long time that at the center of most galaxies is a supermassive black hole. At the center of our galaxy is the black hole Sagittarius A, which is rather tiny at around 4 million solar masses. The black hole that has now been discovered has 30 billion times the mass of our Sun, making it a real giant. It is already certain that this black hole is one of the largest ever discovered. What sounds even more fantastic is the fact that this dark monster was literally thrown out of its galaxy. Yes, you heard that right. Apparently, galaxies can shoot gigantic monster black holes through space, and that can make you feel a bit uneasy. This almost unbelievable scenario was discovered by a research team at Durham University in the UK. James Nightingale, who led the research, explained in an interview that this black hole is at the upper limit of how big we think black holes can theoretically get in the first place. So here we are, definitely dealing with one of the largest black holes of all time, and researchers are quite rightly no longer using the term supermassive, but ultramassive. Our Sun has a mass of approximately 1,989 octillion kg, 1989 with 27 zeros. So, this black giant has a mass of approximately 5,967, followed by 40 zeros. Now you surely want to know where this black hole was discovered and whether it can just happen to fly by. Fortunately, it was discovered at a sufficient distance in the galaxy cluster AEL 121, which is around 2.7 billion light-years away from Earth. Although this object is so huge, it took a trick to discover it at all. Black holes are known to be invisible and only become visible when they are swallowing up matter. But the black giant seems to be inactive at the moment. There is no matter near its gigantic mass, and then nothing lights up. Nightingale and his team discovered the black hole with the help of a gravitational lens. Space-time is distorted by the enormous weight of the giants in such a way that a magnifying glass-like bulge is created. This reveals the black hole and much more exciting data about these mysterious objects. The colorful world of black holes is more varied than you might think, and these objects are without doubt among the most interesting structures in the universe. In purely physical terms, a black hole is an object or a place where the density is so high that neither matter nor light can escape the enormous gravitational pull. Black holes are not actually black, but invisible. Scientists have given this phenomenon this name because our eyes would only be able to see a black hole where they are. Black holes have a gigantic mass, which bends space and time to such an extent that a dent is created, causing this enormous force of attraction. Matter slides in the direction of the dent, and once it reaches the event horizon, nothing can escape. There are 4 different types of black holes: supermassive black holes, medium-mass black holes, stellar black holes, and primordial black holes. Supermassive black holes have between 10,000 and several billion solar masses, while medium-mass black holes have only around 1,000 solar masses. Stellar black holes are about 10 solar masses, and primordial black holes have a mass comparable to that of the Earth's moon. Black holes are the epitome of the superlative of the almost incomprehensible. Inside them, the density is concentrated at a single point at which all known physical forces increase to infinity. The singularity is capable of breaking down large quantities of matter into its constituent parts. The decomposition process already begins in the vicinity of the giant. All matter, even huge stars, is stretched out like spaghetti. We do not know exactly what happens to the matter inside, the only certainty is that it no longer comes out. Presumably, only the pure information remains, and yet black holes increase in weight with every meal. This allows us to conclude that the meals must somehow be stored inside the giants. Einstein did not actually believe in black holes, even though he predicted and calculated them completely correctly. It was not until the late 1960s that more and more astronomical evidence of their true existence was found. Researchers used a brand new radio telescope in 1964 to find a strong source of radiation in the constellation of Swan. More detailed investigations showed that this object could be a black hole. This first real discovery of a black hole became known as Cygnus X1. In the 1970s, the Uhuru satellite mission confirmed the researchers' suspicions. Cygnus X1 is even part of a binary system and has a massive blue supergiant companion star. Astronomers were able to observe the orbit of the companion star around an invisible mass. Why the black hole does not pull in the star is most likely explained by its mass. Blue supergiant stars are among the largest in the universe and can easily rival the size of black holes. Despite these exciting discoveries, mankind had to wait a very long time before the first black hole became visible. Researchers looked at black holes in the center of galaxies, measured gravitational waves, and succeeded in photographing a black hole for the first time. The image shows an orange-yellow ring around a black core in the center of the giant galaxy M87. 55 million years ago, when this black hole emitted the radiation that was then photographed by the researchers, it had 6.5 billion solar masses. The gravitational force of this black hole acts like an engine for its galaxy. The immense gravity in the center and the gravitational pull cause the movement of the stars and also the spiral arms of galaxies such as our Milky Way. When black holes consume matter, enormous amounts of force are released. Sometimes these streams of force are so great that immense radiating jets protrude from the black giants and extend beyond the edge of a galaxy. The James Webb Space Telescope has recently discovered 6 objects that may have been the very first black holes in the universe. If the suspicion proves to be true, these black holes would have existed 500 million years after the Big Bang and would undoubtedly be representatives of the supermassive to ultramassive class. Of course, we have to ask ourselves how black holes could grow so quickly and how they are created in the first place. Researchers agree that the medium and small ones are the remains of collapsed stars. However, the very first black holes could also have been created by dust disks that did not form stars but collapsed immediately to form black holes. The role of primordial mini-black holes, which are seen as relics of the Big Bang, is also still unclear. If many of these small black holes come together within 500 million years, more massive black holes like these could form. Although we already know a great deal about these objects, it is still a mystery what exactly is going on inside them. Since their discovery, there have been fantastic theories that black holes are portals to other dimensions or times. Some say they could be white holes or giant stars in a parallel universe. The only thing that is certain is that the enormous mass of the holes is concentrated at an infinitely small point, and this point is similar to the one point from which our entire cosmos is said to have emerged during the Big Bang. So it's no wonder that there are other crazy theories that we ourselves live in a black hole and that our universe was created from such a black hole. The popular British astrophysicist Sir Roger Penrose even postulated that black holes could have existed before the birth of our universe in his theorem of the cyclic universe. He describes these mysterious objects as structures that possibly transcend time and universes. How do we get information from inside a black hole? A black hole has no surface like a star or a planet. These objects are a bit like drains in a sink. Just imagine your sink drains getting bigger and bigger as more and more plops in. We can only see as far as an immaterial boundary that spherically surrounds the hole, but we cannot see beyond this event horizon, and we could never take measurements there because everything that comes close to the black holes is immediately broken down into its components. Everything that lies beyond the event horizon will, therefore, most likely remain hidden from us, or we may still have a small chance of finding out what is going on inside the black holes. Stephen Hawking discovered that, contrary to all previous assumptions, black holes do let something out, a minimal stream of quantum light particles that can be proven to originate from the interior. We know this ultra-weak stream of particles as Hawking radiation. The quanta that were inside are still entangled with the other quanta inside, even if they fly millions of light-years through space, a connection remains. If one day we were to succeed in extracting the information potential from quanta, we might be able to find out indirectly what is inside the black holes. Quanta are regarded as pure information carriers and building blocks of matter. As you may know, we are on the threshold of quantum computing. These supercomputers are already being tested today, and they will far outshine previous computers in terms of performance and intelligence. Scientists are already hoping that this technology will bring us more answers about the universe. Press subscribe now. There are many more video highlights to come.